Imagine, if you will, a nursery for stars. Not a quiet, peaceful place, but a chaotic, swirling expanse of gas and dust spanning hundreds of light years. This is the Orion molecular cloud, and it was here, some 10 million years ago, that our story begins. Within this cosmic cradle, a giant was born. A pocket of gas, denser than the rest, began to collapse under its own gravity. As it shrank, it spun faster and grew hotter, pulling in more and more material from its surroundings. This wasn't just any star, this was a behemoth in the making. It ignited with a fury, blazing into existence as a massive, brilliant blue-white star, easily 20 times the mass of our own sun. For a brief, glorious period, it shone with an intensity thousands of times greater than the star we know today, true titan of the cosmos. But for stars this massive, life is a frantic sprint, not a leisurely marathon. This young giant was destined for a short and spectacular life. Even in its youth, this massive star was burning through its hydrogen fuel at an astonishing rate. While our sun will happily burn for 10 billion years, this giant was destined to exhaust its core supply in just a few million. And when the hydrogen ran out, gravity, the relentless sculptor of the cosmos, began to win. The core contracted and heated up, igniting the next available fuel source, helium. This new, hotter fire in its heart pushed the star's outer layers outward with immense force. It began to swell and swell and swell some more, transforming dramatically. Its brilliant blue-white fire cooled, shifting to a deep, ominous red. It had become a red supergiant. We know it today as Betelgeuse, the fiery shoulder of the constellation Orion. If you were to place it in our solar system, it would swallow Mercury, Venus, Earth, Mars, and even stretch out into the asteroid belt, perhaps even engulfing Jupiter. It's so vast that its surface isn't a clear, defined edge like our sun's. Instead, it's a boiling, turbulent atmosphere of gas that constantly churns and pulses, like a cosmic lava lamp. This instability causes its brightness to vary, flickering in the night sky as if it has a slow, unsteady heartbeat. For thousands of years, stargazers have watched this celestial ember, a constant, yet ever-changing beacon in the winter sky. It's a star living on borrowed time, a giant in its final, glorious, and turbulent phase. Then, in late 2019, something strange happened. Astronomers, both professional and amateur, who had been tracking Betelgeuse's regular pulsations for decades, noticed it was dimming. And not just by a little, it was fading dramatically, faster than ever recorded. By February 2020, it had lost more than 2/3 of its usual brightness, plummeting to a historic low. The internet buzzed with speculation. Was this it? Was the giant finally about to blow? Was the Great Dimming, as it came to be known, the final signal before a spectacular supernova? The world watched and waited. Scientists scrambled, pointing every telescope they could at the dimming giant. The Hubble Space Telescope captured incredible images that began to unravel the mystery. It wasn't the star itself that was dying, not yet anyway. Instead, it appeared that Betelgeuse had essentially given a cosmic sneeze. A huge blob of super-hot plasma, many times the mass of our moon, had been ejected from its surface. As this massive cloud of gas traveled away from the star, it cooled and condensed into a vast veil of silicate dust, the same stuff that makes up sand and rock. This enormous dust cloud drifted right between us and Betelgeuse, acting like a cosmic smoke screen and blocking a huge portion of its light from reaching Earth. It was an unprecedented event, a glimpse into the chaotic processes of a dying supergiant. By April 2020, the dust cloud had drifted on, and Betelgeuse slowly returned to its former glory. Its familiar ruddy glow restored in the shoulder of Orion. The Great Dimming was over, but it was a stark reminder that we are watching a star on the very edge of its existence. So, what happens next? The Great Dimming was a false alarm, but the final countdown is still ticking. Deep within Betelgeuse's core, a furious battle rages. For millions of years, the outward pressure from nuclear fusion has perfectly balanced the inward crush of gravity, but the fuel is running out. After exhausting hydrogen, then helium, the star has been desperately fusing heavier and heavier elements: carbon, neon, oxygen, silicon. Each stage burns faster and hotter than the last. The final stage, fusing silicon into iron, lasts for only about a day, and iron is the end of the line. Fusing iron doesn't release energy, it consumes it. Suddenly, the fire in the core goes out, the outward pressure vanishes in an instant. With nothing to support it, gravity wins catastrophically. The star's immense iron core, a ball the size of Earth but with more mass than our Sun, collapses in on itself in less than a second. It shrinks down to a ball just a few dozen kilometers across, slamming into itself at a quarter of the speed of light. This catastrophic collapse triggers an unbelievable rebound. A shockwave of unimaginable power erupts from the core, blasting outward through the star's collapsing outer layers. This is the moment of detonation, a type to supernova. In a blinding flash, Betelgeuse will become brighter than anything in the night sky except the sun and moon. For weeks, it will be visible during the daytime, a brilliant new star blazing where Orion's shoulder once was. It will outshine all the other stars in our galaxy combined. It will be the greatest celestial light show in human history. And after the fire and the fury, what remains? The supernova explosion will be devastatingly beautiful. It will blast the outer layers of Betelgeuse, all that hydrogen, helium, carbon, and oxygen out into space at incredible speeds. This expanding cloud of stardust, enriched with the heavy elements forged in the star's core and the explosion itself, will form a stunning, glowing nebula. For thousands of years, this celestial ghost, the Betelgeuse Nebula, will expand and cool, seeding the surrounding space with the raw materials for new stars, new planets, and maybe, just maybe, new life. We are, after all, made of stardust, and this is how that stardust is created and distributed across the galaxy. But what about the core, that ultra-dense ball of matter that triggered the whole event? The collapse will be so intense that protons and electrons are forced together to form neutrons. What's left behind is a neutron star, an object so dense that a single teaspoon of its material would weigh billions of tons. It will be a tiny, spinning relic, just a few kilometers wide, the collapsed corpse of a once mighty giant. From a chaotic birth in a stellar nursery to a spectacular death that enriches the cosmos, the life of Betelgeuse is a dramatic tale of cosmic creation and destruction. We don't know if the end will come tomorrow or 100,000 years from now. But we do know that when it happens, the shoulder of the hunter will blaze with a light that will captivate the world, a final, glorious farewell from a true cosmic giant. Thank you so much for joining us on this journey to the heart of a dying star. If you found the story of Betelgeuse as fascinating as we do, be sure to hit that like button and subscribe for more deep dives into the wonders of our universe. What other cosmic mysteries would you like us to explore? Let us know in the comments below. Until next time, keep looking up.